Number 22. Function f is defined by f of x equals x plus 6 times x plus 5 times x plus 1. Function g is defined by g of x equals f of x minus 1. The graph of y equals g of x in the xy plane has x-intercepts at a0, b0, and c0, where a, b, and c are distinct constants. What is the value of a plus b plus c? Can you do this by graphing? Yes. Yes, you can. I get asked that a lot sometimes, sometimes not in the kindest way either, is when I do a more complicated problem and the response is like, oh, you should just graph it. And yeah, but it's like tools are there to help us after we learn. We learn how to do it, and then we learn how to use the tool to help us do it faster in the future. Ideally. So yes, you can graph this, and what you would do if you graphed it is you would put that in, enter that in separately. And if you're using Desmos, it will realize that it's telling you that g of x refers to the first f of x. And then you're going to look for the zeros, the x-intercepts, the solutions. Those three things mean the same thing. The SAT uses them interchangeably. This is going to be a cubic. They've got three x's multiplied by themselves. It's going to be an x cubed. So it's going to look like this because we know there's three x-intercepts. And there's no negatives in there in the x's, so I know it's going as I drew it and not like that. And they've told us there are three zeros, three x-intercepts, so I know it's crossing three places. And the way you would solve this using graphing is you would just zoom in, you would identify those three solutions, and you would see what the x values for each of them are, and then you would add those together, a plus b plus c, like they tell us to. So that's how you do it graphing. I am going to show you the long way. In this case, it's not that much longer, frankly. It's not a huge difference. There's one coming up in a few where it is a huge difference, and I would be like, just graph that sucker. This one, it's not a huge difference. And it's always good to know this stuff because not every problem that's similar to this and that uses these topics, these math techniques, not every one of them can be solved this way by graphing. So it's good to know what you're doing. All right, so function f is defined by f of x equals x plus 6. And we're going to write all this down. F of x equals x plus 6 times x plus 5. And I wrote too big like I always do. Slide it over. X plus 1. Okay, and my second one, g of x is equal to f of x minus 1. And so what that means is I want to take this, I don't like this green, let's go with red. I'll take this x minus 1, and wherever there is an x in the original f of x, I'm going to put x minus 1 in there instead. And what I get is going to be my g of x. All right, so let's do that. Let's take x minus 1, or x minus 1, and that original plus 6. We got x minus 1 plus 5. And finally, I always run out of room. X minus 1. Oops, need to write it in blue. Write that in blue. X minus 1 plus 1. Okay, so now I need to simplify. I need to combine like terms. And this isn't, this is why I was saying this isn't going to take you that long because, this is not high level right here that they're asking you. X minus 1 plus 6, so negative 1 plus 6 is plus 5. So x plus 5. And then we have x minus 1 plus 5. Negative 1 plus 5 is plus 4, so x plus 4. And then x minus 1 plus 1. Negative 1 plus 1 is 0, so I'm just left with x. Now, if you've done a lot of factoring, you can, and solving for x in factoring, I dare say you can look at these and you don't have to write out the next step. Not that there's any shame in having to write out the next step. I'm just saying no one's checking your work on the SAT is the point I'm trying to make. So if you are familiar with this and you can just look at these and know what the 3 solutions are without writing them down, go for it. Unlike on your math test in your math class, your teacher will not be saying, hey, you didn't show your work. Yeah, I always had a thing with that. I'm like, oh, if I can do it in my head, why do I have to show my work? If you're like that, I feel you. All right, so the way we would show our work in a math class is we would write each of these equal to 0 separately. We want to find out where it equals 0, and there you go. That one I don't have to do anything. It's just x equals 0. And then I would solve them one by one. X plus 5 equals 0, so I would subtract 5 from both sides. So x equals -5. Then x plus 4. To undo that, I'm going to subtract 4 from both sides. I get x equals -4, and then finally just that x equals 0. And there I have my 3 solutions, -5, -4, and 0. The answer was to, or what they were asking for was to add those together. So -5 plus -4 plus 0. -5 plus -4 is -9. -9 plus 0 is just -9. So B is my answer. So yeah, can you solve that with graphing? Yes. Does that mean that you can ignore this and not learn how to do this kind of stuff? No, because you never know how these concepts will come up. And so here, this thing of saying, oh, the x-intercepts at these points, even if you know that you can plug these things into a graph, you still have to know what the x-intercept is, what that means, and how to find it. So knowledge is always good. Knowledge helps you on the SAT, but our answer here is B, -9.
Hey guys, it's Alyssa, and if you're looking for more SAT or PSAT help, go to mathwithalyssa.com. There you can get over 25 hours of test prep. This is for both math and reading and writing, both sections. They also come with practice questions, downloadable study guides, and more. Links to everything are in the description down below. Leave me a comment if you have any questions about this video or any suggestions for future videos. I'm all ears. And if this video was helpful or useful in any way, please let the algorithm know about it. Like, share, comment, subscribe. You know the drill. Thank you so much for watching. Hope you have a great day. See you later. Bye. And I think I slapped my leg because that's something you do. Why did I slap my leg? Why am I slapping my leg as I'm talking? Who knows? I don't know.